Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Well, happy Thursday to you. Oh boy, do we have, as they say down under, heaps of things to do today. I'm going to have to talk like double fast. Well, not really. Okay. First thing I want to show you is my calendar again. I thought they called it a calendar. They actually do. Whoops, that was a close one. Okay, I want to show you this. Month of November, huh? Month of November. So here we are, right here. So we are almost here. So we have next week, right here. We have next week. And then we have Thanksgiving break. So next week, my goal is to finish genetics, the science of inheritance. That's my goal next week. And a week from tomorrow to have a test on genetics. So that's the plan. How about tomorrow? Remember I said no big test, but I am going to give you a quiz and I'm going to tell you exactly what's going to be on the quiz. So if you do not get an A or a B plus or a solid B on tomorrow's quiz, you weren't paying attention. So it's all on you. So I'll do my part. And I'll review with you. Now you've got a white sheet right now. So you've got a white sheet. You're numbering the 10 on that white sheet. We'll probably go a little more than that. These are all the preliminaries. I'll come back to the calendar in a minute. You're taking out worksheet 97F. Did you see that wasn't due? You were going to give us more time to work on it. It was going to be due till Friday. I know I have good news for you. I'll tell you in a minute. So out comes worksheet 97F. This one. Boop, there we go. Okay, your journal, lesson summary 10. Just a heap of stuff need to come out. So you've got your white sheet number to 10. Worksheet 97F is out. Red pen, of course. Red pen. Okay. Is out. Got your journal out. Lesson summary 10, which will be one of the big lesson summaries that will be involved with a week from Friday's test, finishing up genetics. Okay? You've got your lesson planner out, yeah? Like every day. Homework in your lesson planner, you're putting down quiz. And the quiz is going to be on different kinds of genetic traits. We'll do that on the white sheet. Okay. Meanwhile, back to the calendar. So there's Thanksgiving week right there. Not next week, but week after Thanksgiving week. And as you know, we're all excited about having the whole week off. It's going to be fantastic. So, and then we come back in December. And we have 3 weeks in December before Christmas break. So we've got the first 2 weeks, and I'm going to do a creation evolution unit with you, and then we'll review for the final. Are you going to give us a big fat study guide for the final science test? Well, you're going to use your lesson summaries, and you're going to make sure they're all up to date, and that's going to be on you. So hang on to all your lesson summaries. It'll be that, plus a few other things. So, and then so we finish up, looks like the 18th of December is a half day. Many of you will be done with finals. So many of you will formally start your Christmas break on the 18th of December. Right there. Okay? So anyway, there's the calendar. Wanted you to see it. So, Mr. C, how come you've got a sweatshirt on today? Well, it's a little bit cool in the bunker in Mesa today, so I needed this. All right, next. So we're going to go over 97F. So you've got your red pen, but first I want you to have the pen that you started this, right? You were supposed to have started this in class on I want to say Tuesday, right? Because we didn't have school yesterday on Wednesday. All right, so you've got your regular pen that you wrote with, and I'm going to go over this and give you the answers. No kidding. It's an early Christmas present. So here we go. So write the answers in. You should have had the first part of these anyway. Number 1, Walter Sutton, a scientist, genetics scientist, investigated the number of chromosomes. And the organism he worked with was grasshoppers. Chromosomes. And we have since developed the idea that every plant or animal has a certain number of chromosomes that it's got to have to make it look like it is and to work like it works. So every living thing has its own chromosome number. Very important. If it has more or less of that normal chromosome number, it won't be a normal grasshopper or human or humpback whale or whatever. It won't be normal. It's got to have the normal number of chromosomes for that organism, for that plant, animal, or human. Okay, so number 1 was chromosomes. Number 2, the process that produces sex cells, sperm and eggs, meiosis, M-E-I-O-S-I-S, meiosis. Number 3, each chromosome contains 2 identical chromatids, C-H-R-O-M-A-T-I-D-S, chromatids. So, number 1, chromosomes. Number 2, meiosis or meiosis. Number 3, chromatids. Excuse me. I just wolfed down a bunch of peanuts. Part of my lunch. Number 4. This is 97F. In the first division of meiosis, there are 2 cell divisions in meiosis. In the first division of meiosis, chromosome pairs line up and then separate. And I'm going to show you a really cool video of that in a little bit, where you can actually, you can see the chromosomes pairing up and splitting. Number 5, in the second division of meiosis, chromosomes split. Number 4, first. Number 5, second. Okay, the true and false ones now. Mr. C, I don't have any of these done. I know, it's okay. Write the correct answers in. I'm giving you credit for it. Remember? We wish you a Merry Christmas. We wish you a Merry Christmas in November. Little early Christmas present. Number 6. Body cells of humans have 46 pairs of chromosomes. Well, what is 2 times 46? 92. Is that the normal number of chromosomes for humans? No, it's half that. So, in number 6, body cells of humans have 23 pairs. 23 times 2, or 46 total chromosomes. Number 6, 23 for pairs. Number 7, sex cells have half the number of chromosomes. And I'll get to that in a little bit. Number 7, half. Number 8 is true. Number 9 is true. Number 10, a fertilized egg has the same number of chromosomes as the body cells of the parent. Same. So number right over 5, each one is half a point. Number right over 5 at the top. Now here's where your red pen comes in. Initial the score. That you double check that you got it right. Number right over 5. Now you all should have 5 out of 5s. You should, if you paid attention. If you weren't sure of an answer, We're going to take a little break right at the 10-minute mark here coming up in 5 seconds. Mr. Gilbert will help with all this and collect these worksheets. Make sure your name, date, and period is in the upper right-hand corner. So any questions so far for Mr. Gilbert, get clarification, and I'll be right back. Okay, I'm back. Hey, we're going to use that white sheet now. And this white sheet, I'm going to ask you about a number of traits. We're going to do this very quickly. And this is a review for tomorrow's quiz, so pay attention. Mr. C, can we just hang on to this white sheet and use it as a study guide? You betcha. So are you going to pay attention right now? Are you going to do your best first in the practice quiz part and then get the right answers down, so you can be ready for it tomorrow and do well tomorrow? So quiz tomorrow. Here we go. Number 1, what do you call a kind of trait where you get the same kind of allele from mom and dad? Tallness from mom, tallness from dad. Number 1, same kind of allele from both parents. So that's all you have, that one kind of allele. It's number 1. Number 2, what do you call it when you have different kinds of alleles for that particular genetic trait or that gene? So you've got tallness from dad and shorter genes from mom, 2 different kinds of alleles. That form of the gene, the tallness form of the gene. It's number 2, 2 different kinds. Number 3, what do you call it when one trait rules over another? Like you already know that dark usually dominates. Dark hair, dark skin usually dominates. Dark flowers usually dominate. I gave it to you. It's dominant. Rules over. Number 3, dominant. Number 4, what's the hidden one? Doesn't show up. Like lighter colors are hidden. What do we call that? It's number 4. It's recessive. Could you spell that for us? Mr. Gilbert could spell it for you later in the period if need be. Here's how you spell it. R-E-C-E-S-S-I-V-E. Recessive. R-E-C-E-S-S-I-V-E. Recessive. So number 4, recessive. A hidden trait. Number 5. Where there are, we did this on LS10. Many genes for each trait. That's a multiple gene trait. Multiple. Number 5, multiple gene. And you might put right here on your little study guide, LS10. In fact, 5 through 8 come from LS10. LS10. Number 6. What do you call it where you get alleles from both parents and you end up getting both of those traits? Like the chickens that were dark and light, 2 different kinds, and the offspring, the children, ended up having both traits. So that is codominant. Number 6, codominant. You got that? C-O, dominant. Number 7, what do you call it where you've got 2 alleles and neither of them show up in the offspring? There's sort of a tweener trait. Like you remember the red and white snapdragon flowers, and what did they produce? There was a red allele, white alleles in the parent plants, and they produce pink flowers. So it's a tweener in between. That is called an incomplete dominant trait. Incomplete dominant. Number 8, what do you call it where there are many genes causing a trait? Many genes. That's multiple allele. Multiple allele. Okay. I'm sorry. It's polygenetic. Come on, Mr. C. I wrote the wrong answer down. I'm sorry. Number 8 is polygenic. For many genes. Polygenic for number 8. Polygenic. Number 9, this will be half each. What are, how should I say this? Okay. The sperm and the egg are responsible for this trait. So, which trait is it? Sperm and egg are responsible for this trait. What is that? So that's number 9. That's a sex trait, whether male or female. That's what it means. So it just means, what is your sex? Male or female? Boy or girl? What is it? Mr. C, we haven't learned how you get to be a boy or girl yet. That's right, you haven't. When are you going to teach that? Probably tomorrow. It's very interesting and easy to learn, easy to remember. So number 9, sex trait. And then number 10. So 9 was sex trait. And this will be 10, 11, and 12. So what is the kind of genetic material called? First of all, they're all microscopic, but what are the light and dark chains called that you get 46 of, 23 from mom, 23 from dad? What are they called? That's number 10. So what is that? The biggest chunks of genetic material. You get 23 from mom, 23 from dad. They're chromosomes. Number 11. What are the light and dark areas on the chromosomes that cause individual traits? What are they called? It's not alleles. I'm not looking for alleles here. So, what are the light and dark sections called on the chromosomes? And there are hundreds on each chromosome. They're called genes, and alleles are a form of those genes, right? And number 12, what are the complex chemical molecules that make up genes called? It's kind of like the basic building block of genetic material, or chromosomes. And it's the massive argument that there has to be a God. So what do you call it? And I'm going to give you a massive hint. So it's chromosomes, and then the genes, the light and dark patterns, and then the genes are made of deoxyribonucleic acid, DNA. That's why we shorten it, because it's a big fat chemical compound, deoxyribonucleic acid, DNA. So number 12 was DNA. All right, so it was chromosomes in 10, genes in 11, DNA in 12. And then 13, I'd like to finish this up and then have you watch a little video. In 13, you know that the environment of especially a human, the environment of a human can greatly influence the chromosomes and cause them to change and be abnormal. And I give you a big example of that. I mentioned cigarettes and cigarette smoke. Not good. Not good. And I'm praying for you right now that there won't be any of you who are tempted to start smoking, because it can be extremely addictive due to the chemical in cigarettes. You don't even want to start messing around with them. It's all bad. If you get addicted and then you're a long time smoker, and sometimes people will go, well, I won't get addicted. Yeah, you will, because nicotine is the chemical in cigarettes is so addictive. That's why people, if you've ever wondered if you're around people who smoke and you go, well, you know that it's so harmful for you. You know it can cause lung cancer. And then the lung cancer is a horrific, terrible kind of cancer, and it often kills someone who gets it. So, yeah, I know all about that. Well, why won't people quit? Addiction. It's so addictive. Can't break the habit. So if you know anyone who's a cigarette smoker and they've tried and they want to stop, pray for them. It's an addiction. They can't stop. They want to stop. They know it's bad. They know it can cause lung cancer, but a lot of times people just can't stop. So anyway, so 13 was name an environmental factor that can really affect the genes and chromosomes. Cigarette smoke. There are lots of others besides, but that's sort of a massive example. Okay, so there you have it. Okay, so how are we doing time-wise? Good? Good. Now, here's what I want you to do in your journal. In your journal, I want you to write down 2 words, and I'm hoping Mr. Gilbert will help me out here and write these 2 words on the board. And you can put them in a genetics page in your journal. So I'm hopeful you'll put these 2 down. Okay? Here we go. You ready? One of them is mitosis. M-I-T-O-S-I-S. So you're going to have like 2 sections. One of them at the top, mitosis, and you're going to write a number of things about mitosis. And then about halfway down, write meiosis or meiosis. It's M-E-I-O-S-I-S. So there's mitosis at the top, M-I-T-O-S-I-S. And then there's meiosis, M-E-I-O-S-I-S. They're close. But they have different things that happen in these stages. Now, number 1, mitosis. So you've written it at the top of a journal page. First of all, mitosis occurs in body cells. So all you want to write down is body cells beside mitosis. That's where it happens. It's a kind of cell division. It occurs in body cells, like just skin cells, or like cartilage cells. Just normal body cells. That's where mitosis happens. Now, up above mitosis and meiosis, it strikes me that you should write this. You should write cell division. 2 kinds of cell division at the top of this page. 2, cell division. And you can abbreviate cell, C-E-L-L, D-I-V-I-S. 2 kinds of cell division at the top. Have you all done it? Did you all do it? Mr. Gilbert is encouraging that to happen right now as he wanders around. Cell division. So mitosis happens in body cells. And here's what happens. There are 46 chromosomes in body cells. So you're going to write 46C, or abbreviate C-H-R-O-M. In body cells, so right underneath body cells, you're going to write 46. I don't know if I gave it to you right the first time. 46 chromosomes make a body cell make an exact copy of the chromosomes, and it makes an exact copy of that kind of cell. Your cells are constantly dying, and then before they die, they divide and make a new cell. So the outer cells all over your body are constantly dying and flaking off. That's why you get flaky skin. And a lot of the dust, house dust that is around is due to skin flaking off people. Ooh! Yeah, trust me. That's what it is, a lot of it. Okay, so 46 chromosomes. And right before they die, a cell that's dying reproduces itself, mitosis, and before it does that, it makes an exact copy of the 46 chromosomes. They move over into each cell. This one dies, and this one is a brand new one with the same 46 chromosomes, and it just replaces the ones that die. Pretty cool that God designed it that way. It is so awesome and so amazing, and so gives God glory. Okay? So body cells reproduce themselves. It's a kind of cell division. They start off with 46 chromosomes. They copy those chromosomes into a new cell. The one dies, and the new one has the same 46 chromosomes. And that'll happen to it in a few months, probably. Your outside skin cells are constantly dying and renewing themselves. Isn't that cool? Now, if they just died, that would be the end of you, if you didn't get new ones produced all the time. Okay? It's happening throughout your body in the trillions of cells in your body. Mitosis, cell division. Now, there's a second kind of cell division. Is it meiosis? Yep, you wrote it down below. Meiosis. Now, meiosis occurs in sex cells, sperm and eggs. So you're going to write that under meiosis. It happens in sex cells, which put an equal mark, and then put sperm egg cells. So it happens in sperm and eggs. And it's really cool the way God worked this out. Only He could plan for this. Well, only He could design these two cell division processes. They're over the top complex the way it is. Do they prove that He exists? Absolutely. They're so amazing. They're just, wow. You just want to go, we worship you, Lord. You are so amazing that you can create processes like this. Anytime you have a process like mitosis or meiosis, you just go, you're amazing, God. Seriously. Do you do that? I do. I don't raise my hand. My hand's like that. But there'll be some times when I think about this and I'll just bow my head and go, I worship you, God, because you're so awesome. Your creation proves how amazing and awesome you are. It's what it's supposed to do. It says in Romans 1. It's designed to glorify God, make Him look good, to prove His existence. Complicated things. Okay. Cells, mitosis, meiosis, DNA, just over the top. Okay. Another thing about meiosis. Get this. Now, you know how in mitosis, ordinary body cells, what do before they die? They copy the chromosomes. And then the one dies, and the one that was made still has the same number, 46. Now, that cannot happen in sex cells. That can't happen in sperm and eggs. Can you see why? So you've got a sperm and an egg. Okay, they've got 23 chromosomes in them, so you'll want to write that down, 23C. Sperm and egg cells have 23 chromosomes. An egg cell, the mom's egg cell, 23 chromosomes. A dad's sperm cell, 23 chromosomes. Now, do the math in your head. All right? Let's say the sperm cell copies the 23 chromosomes, which actually it does, but I don't want to go there because it'll confuse you. The egg cells copy the chromosomes, but then they usually divide. But let's say they didn't divide. So you've got 23 and it duplicates. What do you have now? 46. So you've got a sperm cell with 46 chromosomes, and you've got an egg cell with 46 chromosomes, and they combine to make a zygote. Any problem with that? Oh, yeah. So how many chromosomes would this zygote have? If you had 46 in the sperm, 46 chromosomes in the egg, and they combine, how many would you have? 92. What's the normal human chromosome number? 46. So would you have a normal human? No. Would it live? No. It would be so abnormal it wouldn't survive. That zygote would die. Okay? So you know what God did? in meiosis. So cool. So a sperm cell has 23. It duplicates those, 46, and then it, exact copy, and then it divides. So it divides, so now there's 23. Isn't that what it should be? Yes. The same thing happens with egg cells. So sperm and egg cells divide twice. Meiosis, there's 2 cell divisions. So you want to put that down for meiosis. For meiosis, 2 cell divisions. Did God have to plan that? Oh yeah. Did he? Of course. He's the Lord of the universe. There's nothing he doesn't know. So of course he knew about this. He designed it that way and makes it happen. So sperm and egg cells, meiosis, there's 2 cell divisions, and then you get down to the right number of chromosomes that a sperm and egg should have, 23. So you've written this about meiosis. It occurs in sex cells, aka sperm and egg cells. There's 2 cell divisions, and there's 23 chromosomes in each sperm and egg. So that when they combine with a sperm or an egg, there's 46 in the zygote, the normal number. So meiosis, 2 cell divisions, 23 chromosomes, okay? And it happens in sex cells, sperm and egg cells. Now mitosis happens in body cells, 46 chromosomes. And how many cell divisions? Show me on your finger. Mr. Gilbert can see it. How many times do body cells divide? You're showing a number. Only once. 1 cell division in mitosis. Mitosis, 1 cell division, happens in body cells, 46 chromosomes, and they divide, and there's 46 in the new cell. Meiosis, 2 cell divisions, happens in sperm and egg cells, 23 chromosomes in each sperm and egg. All planned out, and it had to be that way, or it would be abnormal, wouldn't work. So, amazing the way it works. Really cool. Now, I'm going to give you your homework, and you're going to have some time to work on it. Here it is. Okay, and it's up in RenWeb as well. So homework for Friday, here it is. Well, wait a minute, we've already got to review the little study guide on traits. Yes, you do. So quiz, short quiz on traits, and this homework. You've got to read pages 109 through 111, 111. 109 to 111, 109 to 111. So you're writing that down in your lesson planner, right? Some of you already wrote it down because it was up on the board. Actually, I'm sorry, you saw it in RenWeb. 109, 109 to 111. Read those 3 pages, and then I need 12 bullet facts on a separate worksheet that Mr. Gilbert is going to give you. I need 12 bullet facts on that information. You might want to space out like 4, 4, and 4. 4 on 109, 4 on 110, 4 on 111. 4 key facts from each of those 3 pages. Bullet facts, not complete sentences. Neat job, skip lines in between. Okay, ready for tomorrow? How much is it going to be worth? I don't know, I haven't decided. A minimum of 6 points, maybe 12. Might be 12. So do a wonderful job on those. You're going to have time to work in class for the next few minutes after Mr. Gilbert answers any questions for clarification, etc. Okay, it's on RenWeb as well. So have that ready to go tomorrow on Happy Aloha Friday. See you then with my Happy Aloha shirt on. Adios, Mr. Gilbert.